Hello and welcome. In this video, we will discuss what is linear regression and how we use it. We will discuss the linear regression algorithm and their concept and the code for regression. Here, we have a simple plot of our values. We are plotting our independent and dependent variables together, and by these coordinates, we are getting these green dots. Every dot represents one value. Basically, we want to calculate the distance of this plot and the line that we want to fit in. Line starts from a random position. We calculate the distance of this line and the plot, and then we start moving this line towards these points till it reaches to a position which is declared as best fit position, where the distance of this line and this element is least. That is the core concept of the integration. Now, a lot of things plays a role and mathematics is also involved, which we are not going to discuss at the moment, but we will discuss the code implementation of this algorithm. I gave you a simple example of how the equation get in and the basic mathematics behind it. So y equals to mx plus c is the equation of line, where m is the slope, c is the intersection. This m gets updated and because of which the line keeps moving. M gets updated by m equals to m, the old one, minus lambda derivative of loss divided by the derivative of the old m. Now, because of this value, this m gets updated and this line keeps moving. Now, let's see how it really gets done. So, guys, we are going to talk about gradient descent here. Gradient descent is a very important and very, you can say, in-depth concept. Gradient descent is a concept where we are optimizing the algo, we are optimizing the data, optimizing the model, and we are trying to get our best fit position, or you can say we are trying to reach our global minima. In this image, you see this yellow portion, this is your global minima where you want to reach, and you're trying to reach here by taking these steps. Every time you take one step and try to reach this global minima, you may observe the steps are really big initially, and as the position goes on and as the, you can say, work goes on, the image, the step size start to reduce. They are getting smaller and smaller. We achieve this by having a simple solution that we keep changing the lambda position. That is why this and this step size is different. So how do we achieve this? How do we really get this job done? Basically, what we are doing here, we are updating a lambda value, which is a constant value, and this constant value can be anything. Basically, it is a very small constant value. It can be like 0.001, okay, and it can start getting smaller and smaller as we reach to the global minimum position. More closer we get to the initial position or this line, more smaller the value of lambda gets, and we reduce the size of step to reach the global minimum. In case of we are not making the steps smaller, we have a chance of jumping here and there and never reaching the global minimum. To avoid that, we reduce the step size as we go closer to the global minimum. Now, question also arises that why we don't keep the value the small from the very start. Reason for that is, guys, the step will be very small and it will take forever to reach this global minima. Okay, it will reach the global minima definitely, but it might take forever. We don't want to waste that much time, and this is called algo optimization basically. And let's see a practical implementation of linear regression. So here we have taken a data set which is diabetic data set from the linear from the data set of a scalar. It's a data set where we have all the array form value, and we are using this data set to fit a linear regression. To fit in a linear regression model, first we have to import these libraries. We are importing matplotlib, numpy, dataset and linear model, mean square error and R2 square. So when we done importing these things, we move forward. These library has been imported, As you can see, the running part is done. Then the next step, what we are going to do, we are going to create these two variables, diabetic x and diabetic y. We are loading these diabetic x and y by saying return x and y true. Now, after getting this value, we have independent value in x and dependent value in the y. Let me show you what the values are we have in x. These are my x values and these are my columns. Okay. I check the shape. The shape is 442 10. What I decided to do, I have decided to pick only one column, that is second column, and I'm choosing the second column randomly. Of course, we don't want to reshape at the end by -1 and +1. So we decided to do this like this. We are giving a none here and giving the second column here. So it will give me a proper shape of column when it slices it. I run this and I have this shape now. 4421. I'm also showing you the shape of x and y. So y is look like this. We have this values which are our target value for diabetic data set, and the shape of x is this, shape of y is this. Once you are done with this, you always want to split it. Now guys, we always have the option of train test split by model selection, but here I am going with a more generic way of slicing it and getting just 20 values at the end as my test value, and remaining data is my train value. When I do this splitting, I go for the shape printing. So this is my shape 4221 and 422 is my X target train and the Y train. 21 and 20 is my test shape. Now I'm creating a variable or object of the class linear model regression. LR is the name. I will just fit my data in the LR. When I fit my data in the LR, it means I'm giving my value to this. Means I'm doing the training part. LR model, the linear regression model, is learning from my data set when I run this. So I have not run it. First I have to run this, then this. Now it has learned from my data set. After learning, we will predict. So prediction is very simple. Model has learned from the input and the output. Now we only give the input and ask model to give us the output. The output is saved in your variable diabetic y pred. Now we will check in the y pred what is the value and we compare it to the actual values. I run this and I run this. So these are the output that I have achieved from my data. Now guys, training accuracy, training scores depend greatly on how much running you have done, how much training you have done for your model. So let's move forward. I am printing the coefficient, the beta value here to show you what is the value. And then I am printing the mean square error. The mean square error is 2248. You can just square root this to find the RMSE. I'm also printing the R2 score, which is 47 in this case, as the training was not enough for the model to learn from it. So if the training is not enough, it takes less accuracy, it give you less value. If you want to increase that, I suggest you go for multiple training or cross validation kind of steps. Now we are printing the shape here and we are also plotting it. So plot it, I'm using a scatter plot and a line chart. In the scatter plot, I'm giving the test diabetic and y test diabetic, which is black in color. Then I'm giving the test and the test predict. So one, the line is the predicted value and the scatter value are the actual values. I'm running this and I get this. As you can see, line has not been fitted very accurately. The angle could have been little downer from the back side and could have been a far better fit. We also observe we have one or two outliners in the data set which could have been removed while working on it. But again, talking about those steps and techniques is not the part of this video. We are keeping it for the other videos. I hope you like the video. I hope it was informative. So we have covered linear regression, their learning part, their training part, their testing part, and the accuracy check, the score check, and then we have also plotted our data to see how the performance is from our model and the prediction part. That is all for the video, guys. Thank you for watching.